Welcome all of you. Welcome. Am I audible? Students. Yeah, this mic is on. Welcome all. Is my voice is coming to you? Audible, visible properly? Hello. Good morning. Yes? Okay, okay. Very good. Good morning, everyone. Good morning. Good morning. Good morning. Yes, Chintu. Very good morning. Yes. Okay, okay. Okay. Okay, very good morning, everyone. Good morning. Yes. So, what we were learning in the previous class, we were covering vectors. Okay, our aim is to become a doctor in the NEET 24. We will crack the NEET 24. Okay, and to crack NEET 24, we need to cover the complete syllabus of physics with very deep understanding of all the concepts. So, we were learning vectors in the previous classes. Yes. Good morning, everyone. Good morning, Asha. Good morning, Manisha. Okay. So let us start our whatever. For 1 minute, I will recap what we were learning in the previous class. We were doing the vector component. We were learning about the vector component. A vector may be divided in components. If you take 2 dimension, then vector may have 2 components in x direction and y direction. 2 components of vector may be created in x and y direction. The x component, let's say that is ax vector, y component, let's say that is ay vector. Then vector A can be written as its component in x direction plus component in y direction. This is how vector can be written. If we know the vector in component format, we can know the magnitude of vector. If we know the vector in component format, we can calculate the magnitude of vector. How to find the magnitude of vector? Magnitude means length of vector. How to find it? Length of vector is root over x component square plus y component square. This is for 2D. In 3D, AZ square is also there in 3D. So in 2D, this is how we will find the magnitude of the vector. Sometimes they ask what is the angle created by vector. What is the angle created by vector with x or y axis? If you want angle with x axis, theta with x direction, so start with y component of vector, divide it with x component of vector. And if you want angle of vector with y direction, angle of vector with y axis, you want this theta y, angle of vector with y direction. To calculate angle with y direction, start with x component tan inverse ax upon ay. So these are formulas. If we know the vector in component format, we can calculate the length of vector and its angle. If someone gives us length of vector and angle, then we can also calculate the component. The x component of vector will be hypotenuse, which is a here, into cos of theta with x direction. And y component of vector will be a into sine of theta with x direction. Angle is made with x direction, so y component will be in sine. So if we know the angle and length of vector, we can find the component. And if we know the component, we can find the length and angle. Okay, inversion can be done. With help of component vector, we can find the length and angle. With length and angle, we can find the component. Okay, so 2D we have covered some questions on this. Same thing we have discussed for 3 dimension also. Same thing we have discussed for 3 dimension also. In 3D, vector has 3 components: ax, ay, and az. The x component may have length ax into I cap, ay into j cap, az into k cap. What is this ax, ay, az? Ax, ay, az are component or projection of vector in x, y, z direction. This is vector's x component, this is y component, this is z component. How to find these components? If we know alpha, beta, gamma are angle of a vector with x, y, and z axis. If I know angle of vector with x axis, y axis, z axis, then I can calculate the ax, ay, az. This x component is given by a into cos alpha, angle with x axis, so a into cos alpha. Length of vector into cos alpha gives x component. Length of vector into cos beta, this is angle with y axis, so we'll get y component. And similarly for z component, length of vector into cos gamma. So if you know alpha, beta, gamma and length of vector, I can know ax, ay, z. If I know ax, ay, z, then I can calculate the length of vector. Length of vector is given by root over ax square plus ay square plus az square. If I know ax, ay, az, then I can calculate the length of vector. And now if I know length of vector, a, then ax by a is cos alpha, ay by a sin cos beta, az by a cos gamma. Okay, we can also calculate cos alpha, cos beta, cos gamma using ax, ay, az and a. So all inversion here can also be done. We have not done any question on this. And one more property, I almost forgot to tell you the property, revise you the property. Cos square alpha plus cos square beta plus cos square gamma is 1. Cos alpha, cos beta, cos gamma, they are called direction cosines. Yes, direction cosine. Direction cosine. So sum of square of direction cosine is 1. We have covered this property. And instead of cos, if I take sine, sin square beta plus sin square gamma, this comes out to be 2. Sin square alpha plus sin square beta plus sin square gamma. Okay. So yes, this was the quick recap of the previous class. Okay. Now let us start solving some question. We have not covered question in the previous class. So today we will cover question. Okay. If a vector makes 45-degree and 60-degree angle with x and y direction, x and y axis, find its angle with z axis. So my first question is, a vector is making 45 and 60-degree angle, 45-degree and 60-degree angle with x and y. Find the angle of vector with z axis. Try this. Find the angle of vector with z axis. Find the angle of vector with z axis. Vector is making some angle with x axis and y axis. Find the angle of vector with z axis. Try this. Vector is making angle 45-degree and 60-degree. 45-degree and 60-degree with x-axis and y-axis. Find the angle of vector with z-axis. We can use the property. Remember, in last class also I have told you, we will use these properties. If I know alpha, beta to find the other angle, I can use this property. Some are giving me correct answer. Sham, your answer is wrong. Others' answers is correct. Asha, sorry, your answer is wrong. Blessy, your answer is also wrong. Cos square alpha plus cos square beta plus cos square gamma. Gamma we need to determine. Angle with z-axis is not known. So how to determine gamma? Just use this equation. We can use either of the equation. So I will go with cos equation. I will write cos square alpha. What is alpha here? 45-degree. Cos square beta. What is beta here? 60-degree. Plus cos square gamma. Gamma I need to determine. Sum of these three must be 1. So solve this. Cos 45, 1 by root 2. Square of 1 by root 2, 1 by 2. Okay. Cos square 60, 60, 1 by 2. Square of cos 60, 1 by 4. Plus cos square gamma equal to 1. So for finding cos square gamma, let us take these two on that side. 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4. 1 by 2 plus 1 by 4. This must be 3 by 4. So I am taking 3 by 4 on that side. So 1 minus 3 by 4. Here it is positive, so on that side that will be negative. 1 minus 3 by 4, 1 by 4. So my cos gamma, if I take root, my cos gamma, cos square gamma is 1 by 4. So cos gamma may be plus minus 1 by 2. Here students usually commit mistake. Cos square gamma is 1 by 4. Cos square gamma is 1 by 4. If you take root, then cos gamma may be plus minus root 1 by 4. That is 1 by 2. Students usually forget about this plus or minus sign. Why plus and minus should be there? If you square both things, if you square plus half, you will get 1 by 4. If you square minus half, you will also get 1 by 4. So there are two possible values of cos gamma here. Always remember, whenever you have square of something and you are taking root, there will always be two signs, plus or minus. There will be always two signs, plus or minus. Now, if you take cos gamma is plus half, for plus half, you will get gamma is 60, or for minus half, you will get gamma is 120. So there are two possible answers of gamma. Okay. So these are my two possible answers. Angle with z-axis, maybe two values, 60, 120. 60, 120. Is this understood? Angle of vector with x direction and y direction was given, and we were calculating angle of vector with z direction. Okay? And you can see one more thing here. The sum of angle with x and y is not 90. The sum of angle with x and y is not 90 because we are in 3D. In 3D, it's not necessary that sum of angle with x and y must be 90. In 2D, it should be. If vector is in plane, then x-axis and y-axis will have angles which sum up to 90. But here it's not necessary. In 3D, it's not necessary. 3D, this condition is necessary. Thus, cos square alpha plus cos square beta plus cos square omega, sum of square of direction cosine must be 1. So if I know the component of, if I know the angle of vector with x, y, z, I may write vector also. Now part 2 of the question. If magnitude of a vector is 10, write a vector in component format. Do it as a magnitude of a vector is given, write a vector in component format. Magnitude of a vector is given, write a vector in component format. Write this. Magnitude of a vector is given. There is a length of vector. A is given. You need to find components. Matlab x, ax, ay, az. Find ax, ay, az. How will you find that? How will you find ax, ay, az? Remember this. Ax, ay, az are nothing but length of vector into cos alpha, length of vector into cos beta, length of vector into cos gamma. And we know alpha, beta, gamma. Just use this. So it's very easy question. Length of vector is given. Length of vector is 10. Ax, that must be 10 into cos of alpha. What was alpha in the previous part? Alpha was 45, I suppose. 45? Yes, alpha was 45, beta was 60. Cos 45 is 1 by root 2. Tan into 1 by root 2. Tan into 1 by root 2 is 10 by root 2, or you can write this as 5 root 2. Tan into 2, 10 is 5 into 2, so 2 by root 2 is root 2. Ay, length of vector into cos of beta. What was beta in the question? 60. Cos 60 is half, so it is 5. Az, tan into cos of gamma. Remember, cos gamma is plus minus half. There were two answers of cos gamma. So tan into plus minus half. So we'll get plus minus 5. So if you know the component in x, y, z direction, we can write the vector. Now a vector must be x component 5 root 2 I cap, y component 5 j cap, and z component which is plus minus 5 k cap. This must be our a vector. Is this clear? Plus minus. Many are doing this mistake, plus minus. Yes. Some of your answers are also correct, very good, but no one has given me this plus minus answer for z component. There may be two answers of z component, yes, because this cos gamma is plus minus half. So plus minus 5. Is this completely understood? Ardhaminda, clear? Yes, Hari. Very good. Okay, very good. So if anyone give us length of vector and its angle with xyz, I can write vector in component format. Okay. Now I will do reverse question, different question. I will give you vector. You need to give me its angles. A vector is I plus 2j plus k. Find its direction cosine and angle with z-axis. A vector is given. You need to tell me its direction cosine of the vector. You need to tell me the direction cosine of vector and angle of this vector with z-axis. Give me the direction cosine of vector and angle of vector with z-axis. Direction cosines are cos alpha, cos beta, cos gamma. How to find those? We know ax, ay, az, component in xyz direction. We can know the length of vector with them. Remember, x component of vector, which is 1 here, that is given by length of vector into cos of alpha. And length of vector here, length of vector is magnitude of this, which is root over 1 square plus 2 square plus 1 square. Okay, 1 square plus 2 square plus 1. 2 square is 4, 4 plus 1 plus 1, 6, root 6. Length of vector is root 6. So this A is root 6 and AX is 1. So cos alpha must be 1 by root 6, cos alpha. Similarly, cos beta, direction cosine, y component is 2 and length is root 6. AY upon A, component in y direction upon length of vector. Similarly, AZ upon A must be cos gamma. Again, Z component is 1 here, so 1 by root 6. So value of direction cosine is 1 by root 6, 2 by root 6, 1 by root 6. Clear? And I also want angle with z-axis. So how to find angle with z-axis? How to find this gamma? We know cos gamma. We know cos gamma. So gamma can be written as, if cos gamma is 1 by root 6, then gamma must be cos inverse 1 by root 6. Simple. If we know value of cos gamma, we can give you gamma. Gamma must be cos inverse 1 by root 6. This will be the answer. This will be the angle with z-axis. Is this clear? Very simple question. If we know the vector in component format, we can know the length of vector. We can also know the angles with xyz axis. So we have done both kind of question. If they give us length and angle, we can find the vector in component format. And if they give us in component format, we can find the length and angles. Understood? Is this point clear? We have done both kind of question. And in this question, we have calculated direction cosines. Yes, okay, very good. So vector component we have now covered. Okay. So after vector component, now we will start some other types of questions. Okay. We have discussed Lamy's theorem in the previous class. We have discussed when the sum of three vectors may be 0. Okay. So let's go back to that point. The concept of equilibrium. If sum of three vectors is 0, sum of vectors is 0, they are in equilibrium. Sum of vectors is 0, they are in equilibrium. And for special condition, for special case of three vectors, sum is 0, case of three vector, they create a triangle. I have told you about Lamy's theorem in the previous class. Suppose these are my vectors, A vector, B vector, and this is your C vector. If they are arranged on the sides of triangle like this, so that they create a closed triangle, then their sum may be 0. If this is the case, they follow a relation. In front of A vector, this angle is alpha. In front of B, this is beta. In front of C, this is gamma. They follow sine law. We have covered sine law in the previous class. What is sine law? Length of A vector upon sine alpha, length of B vector upon sine beta, length of C vector upon sine gamma. These three are equal. This is called Lem's theorem. We can arrange this vector in a different way also. We can arrange these vectors in a different way also. I can take this A vector here. I will arrange the B vector such that the tail of B vector on the tail of A vector. I will arrange the C vector such that their tail is again on the same point. I can also arrange these three vectors by tail by tail. Same three vectors I am arranging by tail by tail. Angle was alpha beta gamma. So let us show alpha beta gamma here. Okay. Now in this figure, in this particular diagram, I am showing angles like this. Okay, I am showing angle like this. Opposite to A, let's call this angle X. I am calling this angle X. Opposite to vector B, I am calling this Y. Opposite to vector C, I am calling this Z. X, Y, Z are now angle. I am taking X, Y, Z as angle. Why I am not taking alpha, beta, gamma? Because alpha, beta, gamma I have used here. So I am using different letters here. Okay, because these three are different angle. This beta is not angle between A and C. This beta is not angle between A and C. Angle between A and C is not beta. Actually, angle between A and C, if you try to observe angle between A and C, this is your C vector, this is your A vector, this is the angle between A and C, which is pi minus beta. So angle between A vector and C vector, this is pi minus x, y. I was taking this as y. Okay, this is y. So pi minus beta, I am calling it y. Okay, so I have called angle xyz here. Now the same Lem's theorem can be written in these angles also. So A vector's length upon opposite angle sine of opposite angle. So we can write here length of A upon sine x, B vector's length upon sine of opposite angle, sine of y, it should be y, and length of C vector upon opposite angle sine. So same Lem's theorem I am writing in a different way. This is again Lem's theorem. We have covered Lem's theorem in the previous class. This is another way of writing Lem's theorem. Okay, why I am giving you Lem's theorem in this format? Because sometimes questions are given in this way. Let us solve a question on this. This is your in gym book. In gym book, you will find this question. See this question. This kind of question. Okay, I am not giving exact question of gym book, but I am taking a question which is a lot similar to question in gym book. Okay, two vectors are arranged like this. This vector has length 12. This vector has length 5. This vector is length 12. This vector is length 5. Okay. There is another vector here whose magnitude we do not know. These three vectors, let's call them A, B, and C, are summed up to 0. It's given that A plus B plus C is 0. Then find magnitude of C vector. And you can see in diagram that A and B are perpendicular. Find the magnitude. Class is for 1 hour today. Okay, it is up to 9:15. Find the angle between A and B. Angle between A and B is given. Find the magnitude of C. So very simple question on Lem's theorem. We need to find length of this vector, length of other two vectors, and their angle is given. Think what we can do. Length of two vectors is given, length of other vector is to be determined, and it is given that their sum is 0. That sum is 0. So what we can use? That sum is 0. So C vector must be minus of A plus B. C vector must be minus of A plus B. If you take magnitude here, so magnitude of C vector must be, for negative sign, magnitude will remain same. It should be a magnitude of A plus B. Just give the magnitude of A plus B. A and B are perpendicular. So their magnitude must be root over 12 square plus 5 square, that is 13. So answer is 13. You will ask me how Lem's theorem is used in it. Wait, I will give you answer. This is 13. Now if I ask you what is the angle between C vector A vector and angle between C vector and B vector, then you will need Lem's theorem. Find angle between A and C and A and B. A and C, B and C. Now find angle between C vector and other vectors. So for this we can use Lem's theorem. Okay. Length of C vector upon sine of opposite angle, which is sine of 90. That must be equal to length of A vector upon sine of this angle. Length of A vector is 12, and this angle between B and C, let us call this something. Between B and C, this is x, this is y. So this is x, this is y. So then 12 by sine x. So you can find sine x here then. Sine 90 is 1. Length of C we know it is 13. So sine x must be 12 by 13. And similarly we can find sine y also. Here. Is this part clear? Length of C vector we have calculated here. It is 13. If length of this vector is known, I can know these angles using sine law or Lem's theorem. What I am doing here? Length of this vector upon sine of opposite angle. Length of A vector upon sine of opposite angle, which is x. So C by sine 90, 12 by sine x, they must be equal. So by cross multiplying it, I can know the sine x. Value of sine x is 12 by 13 here. So x is sine inverse 12 by 13. So this is how we can find the angles between vector. And sometimes they give us angle, then we can find the magnitude of vector. Clear? So there is one question in your gym book. Yes, very good. Sine of x, I am finding this sine of x. Okay, so sine x will be this. Yes, sine y will be 5 by 13. Very good. Sine y will be 5 by 13. If you find sine y, that will be 5 by 13. If I know sine x and sine y, I know the angle x and y. Okay. So now we have covered Lem's theorem and a question regarding Lem's theorem. We will see more question on Lem's theorem, but we need to move forward. So we have covered vector component. Now we will start dot product of vector. We'll start scalar product or dot product. Write down products of vector. Products of vector. In vector, we will learn two kind of product. First is scalar, which is also called dot product. The other is vector product, which is also called cross product. Scalar product is called scalar because this gives us a scalar number. If I am scalarly multiplied to vector, with scalar product, I get a scalar number. That's why the name is scalar product. And that is represented by dot. We represent scalar product like this, a dot in between. That's why the name is dot product. Why the name is dot product? Because a dot is in between. To represent scalar product, we use dot. That's why name is also dot product. To represent vector product, we use cross. Hence the name is cross product. The result of cross product is a vector. The result of dot product is a scalar. This gives scalar. That's why the name is scalar product. And this gives vector. That's why the name is vector product. Is this clear? There are two types of vector product. Okay, scalar product and cross product. We will first learn about scalar product. We will first pay attention to scalar product. So let us learn scalar product or dot product. A question usually comes into students' mind, why we are defining two types of vector product. We have not defined this kind of thing in scalar number. If I multiply 3 into 4, there is only one way of multiplying 3 into 4. 3 into 4 is 12. Whatever way you do, you 4 into 3 or 3 into 4, that is 12. There is no two types of product in scalar number. But with vectors, why we have two kind of product? This question usually comes to students' mind. Actually, whatever we are not doing for ourselves. We are not doing any imaginary thing. Okay, all these things are given by nature. Given by nature. Nature tells us that there are two types of vector product. Sometimes two vector quantities by combination gives you a scalar quantity, and sometimes two vector quantity by combining gives you a vector quantity. So, for example, work is dependent on force and displacement. Work is dependent on force and displacement. This is dependent on force and displacement. So work is actually scalar quantity, and force and displacement both are vector. Force and displacement both are vector. So two vector quantity when multiplied gives you scalar. In these cases, we observe that they are multiplied by dot product. They are multiplied by dot product. Okay, force dot displacement, force and displacement are product here scalarly, and they are giving you a scalar number. So in nature, in our physics, we observe that vectors are multiplied in two ways. And sometimes, for example, torque, that is a vector quantity, but that is position vector, r vector cross force vector. So we get a vector quantity with two vectors, r and f. And here I am getting a scalar quantity with two vectors. So in nature, we observe that the vectors are multiplied by two ways. It is not that we are defining like this. It's in nature. Okay. So this is why I was trying to explain why there are two kinds of product. Okay. If you know this thing now, it's very good. If you don't know this, no one will ask you this. Okay. Just try to remember what is the meaning of dot product. Now we will focus on the dot product only. Okay. We will learn the dot product first. What is the dot product? How to define a dot product? Vector dot product, A vector dot B vector or B vector dot A vector is nothing but magnitude of A, magnitude of second vector into cos of angle between them. If you have two vector A, B, A dot B or B dot A, both are same. A dot B or B dot A, both are same. Just like scalar number 3 into 4 and 4 into 3 is same. In same way, A dot B and B dot A is same. What is this? Magnitude of A is length of A, magnitude of B is length of B, and cos of angle between them. Cos of angle between them. This is your A vector, this is your B vector. They are connected tail by tail. Then this is the angle between them. So magnitude of first, magnitude of second into cos of angle. This gives you scalar product. And this is a scalar number. This is a scalar number. There is no direction in it. So scalar product of two vector is this. We can say if I drop a perpendicular from head of B on head of A, this length will be B cos theta. This is B cos theta. This length is B cos theta, isn't it? If this length is B, this is theta, this is 90. So this will be B cos theta. This is B cos theta. Yes, Kusuma, very good. This is B cos theta. Can you see this? This is B cos theta. This is length B. This is theta. So this is B cos theta. Hence, magnitude of first vector into B cos theta. It also means it is length of a vector multiplied with projection or component of B along first, multiplied with projection or component of second along first. So when two vectors are scalarly multiplied. We are finding scalar product of two vector. How to find that? Length of first, length of second into cos theta. And length of second into cos theta, b cos theta also means the projection of second vector on first vector. Projection of second vector on first vector. So we are multiplying length of first into projection of second on first. Length of first into projection or component of second along first. Projection and component means same thing, almost same thing. Okay, component is also projection. Is this clear? What is the definition of dot product? How to find the dot product? Formula for dot product: length of A, length of B, cos theta. Length of A, length of B, cos theta. Dot product satisfy commutative law. Yes, dot product satisfy commutative law. Dot product satisfy commutative law. This is called commutative law. A dot B equal to B dot A. It is commutative law. So how to find dot product of two vector? We know the formula. Now we can find the dot product. Let us solve a question. If length of A is 4, length of B is 2, theta is 60, find A vector dot B vector. Find length of A, length of B is given, angle is also given, find A vector dot B vector. Very good. Answers are coming very good. Very easy question. Solution. Length of A, length of B is already given to us. E vector dot B vector is length of first vector, length of second vector into cos of angle between them, cos 60. So 4 into 2 into cos 60 is half. So answer must be 4. Answer must be 4. Very simple question. Very simple. Very easy to do dot product. Okay. Dot product we now know how to calculate dot product. Length of two vectors must be known and angle between them must be known. Yeah. And you can also see that this answer is a number. So always the product of dot product of two vector gives you a number. It's a scalar thing. It's a scalar. That's why the name was scalar. Okay. Now we will learn the properties of dot product. Properties of dot product. Properties of dot product. Properties of dot product. What are the property? First property which we can see here, the product dot product gives you scalar number. Dot product gives you scalar result. Dot product gives you scalar result. The result dot product is a scalar number. The angle between two vector can be from 0 to 180. 0 to 180. If it is less than 90, we get a positive number. If it is greater than 90, we get a negative number. So dot product may be positive, negative, or 0. Dot product may be positive, negative, or 0. Yes, we will discuss commutative law. Wait. Dot product may be positive, negative, or 0. If the angle between two vector is less than 90, in this case theta is less than 90, we get A dot B positive. If dot product is positive, the angle is less than 90. Both inverse is also true. Okay, whenever you see the dot product result is positive, you will understand the angle is less than 90. Okay, and if angle is less than 90, dot product result is positive. Yes, angle is acute. But if angle is obtuse, like this is your A vector, this is your B vector, here angle is obtuse. Theta is greater than 90. The result dot product is negative. When obtuse angle between vector, we get negative dot product. So it's an easy way to know whether angle is less than 90 or greater than 90 between two vector. Find the sine of A dot B. If sine of A dot B positive, angle is less than 90. Sine of A dot B negative, angle is greater than 90. Clear? But what will happen if angle is 90, exactly 90? If two vectors are perpendicular, angle here is 90, theta is 90, theta 90 degree, A dot B is 0. Theta 90, A dot B is 0. This is a good way to know whether two vectors are perpendicular. If they are perpendicular, their dot product must be 0. Some questions will come, okay, in which you need to find whether the vectors are perpendicular or not. They will ask you, they will give you a vector and they will ask which of this is perpendicular to this, perpendicular to first. So you will find dot product. If dot product is 0, the vectors are perpendicular. Second property of dot product, it may be positive, negative or 0. So we have discussed 3 cases, positive, negative, 0. Understood? Third property of dot product. Third property, it is commutative. A dot B equal to B dot A. This is called commutative law. And they are distributive also. A dot B plus C, you can distribute dot product. It is equal to A dot B plus A dot C. Just like scalar number, we can distribute dot product. It is distributive. Simple. Fourth property. The maximum value of A dot B equal to length of A into length of B. Cos maximum can be 1. That's why the maximum value of A dot B is AB. It is when cos theta is 1 or theta equal to 0. So when two vectors are parallel, we get the maximum value of A dot B. If A dot B equal to AB, it means the vectors are parallel, theta is 0. And this is the maximum of A dot B. The minimum of A dot B is minus AB. This is obtained when theta is 180. Cos theta for 180 degrees minus 1. So minimum value of A dot B is minus AB. It is obtained when the vectors are anti-parallel. If this is your A vector, this is your B vector, you will get minus AB. Maximum value of A dot B is AB, minimum value of A dot B is minus AB. If I draw graph of A dot B with theta, suppose I am drawing a graph, on this axis I am putting the value of A dot B, on this axis I am showing values of theta. If I change the angle between two vectors, for 0 degree, for 0 angle, I will get the maximum value of A dot B, then I will get the cos theta graph. At 90 degree, dot product is 0. At pi, dot product is minus AB. So starting from plus AB up to minus AB. This will be the graph of A vector dot B vector with theta. This kind of graph I will get. A dot B with theta. So A dot B maximum is AB, minimum is minus AB. In between we get 0 for pi by 2 angle. So we have covered the range of A dot B. Is this clear? This is just a graph of cos theta. Why I am drawing graph like this? Because this is graph of cos theta. A dot B is AB cos theta. So I am changing theta. Graph of cos theta will come. Is this graph clear? And why I am not drawing graph for more angles? Because angle between two vectors is from 0 to 180. I am drawing graph from 0 to 180. The graph is created for 0 to 180 angle. Clear? Is this point 100% clear? How to, what is the graph? Okay, very good. Fourth point we have covered. Next point. This was the property. Fifth point. Dot product can be done when we know vectors in component format. So dot product in component format. Before that, just a minute. Before component format, We will multiply, we will take dot product of unit vector. Unit vector. If I multiply I vector with j vector, I will get 0. If I multiply j with k, I will get 0. If I multiply I with k, I will get 0. Why? Because these are perpendicular. I dot j, j dot k, I dot k, all these are 0. Whenever two dissimilar unit vectors are multiplied, we get 0. Why? Because they are perpendicular. I, j, k are perpendicular. Dot product of perpendicular vectors is 0. Dot product of perpendicular vectors is 0. But if I multiply I with itself, I dot I, it will be length of I into cos of angle between them. Length of I cap into length of I cap into cos of angle between them. Now, angle of vector with itself must be 0. A vector is parallel to itself, so it must be 0. So it will be length of I1, cos 0, 1. I dot I, 1. Similarly, j dot j, 1. K dot k, 1. A vector multiplied with itself gives you, this is I cap dot I cap, this gives you 1. I cap dot I cap gives you 1. J cap dot j cap, k cap dot k cap gives you 1. Vector with unit vector with another unit vector, this gives you 0. I dot j, 0. Sixth property. A vector multiplied with itself, a vector dot a vector. This will be length of a into cos of angle between them, which is 0. Vector will make 0 angle with itself, hence this is a square. Length of a square, or you can write mod a square. When you multiply a vector with itself, you get its magnitude square. Dot product of vector with itself gives you magnitude square. Dot product of vector with itself gives you magnitude square. Clear? So this was the sixth property of vector. Seventh, how to multiply vectors in component format. Vector multiplication in component format. Vector multiplication, no, scalar product or dot product. Dot product in component format. It's very easy, very simple form of dot product, very simple form of vector product. Dot product is easiest of the product. If you know vectors in component format, a vector is ax I cap, ay j cap, az k cap. This is your a vector, and your b vector is bx I cap, by j cap, bz k cap. You want dot product. So when you take dot product, I dot other two will give you 0, because I dot j 0, I dot k 0. So I dot I will give you 1, and ax and bx will be multiplied. Similarly, j dot the other two is 0. Only you will get ay by. And last thing you will get az bz. So very easy. You need to just multiply the x components, y components, z components to get the dot product of two vectors. And remember, we will use the signs of ax, ay, z also. So let me give you an example of this. An example. Okay, I will give you an example. A vector is I plus j minus k. B vector is 2i plus 3j. I need to 2i plus 3j, yes. Let us take this minus 3j. 2i minus 3j. Now we will find dot product. Then a vector dot b vector will be multiplication of x component, multiplication of y component, multiplication of z component. What is x component here? In first vector it is 1, in second vector it is 2. So 1 into 2. I will get 1 into 2 plus y component here is plus 1, y component here is minus 3. Use sign also, minus 3. So 1 into minus 3 J component is 1 into minus 3. K component, for the first vector K is minus 1, second is 0, plus minus 1 into 0. Some of you are also giving me answer. Okay, we will check. Yes, so solve this. So 1 into 2, 2. 1 into minus 3, minus 3. Minus 1 into 0, 0. 2 minus 3, minus 1. This is answer, minus 1. Vector product, dot product of two vectors when component format is given. It's very easy. Is this clear? We can get the dot product very easily. Okay, very good. So this was, I think, 8th point or 7th point. Yeah, 7th point. Dot product in component format. Dot product in component format. Dot product in component format we can do. Okay. Now, the vector product of two vector, 8th point. Sorry. Dot product of two vector is mod A, mod B, cos theta. So this can also be used to know the cos theta. Cos theta will be A vector dot B vector upon length of A and length of B. A vector dot B vector upon AB. I can know the cos theta if I know the dot product. Sometimes people give us vector in component format. AXI cap, AYJ cap, AZK cap. And they will also give you B vector in component format. BXI cap, BYJ cap, BZK cap. Then I can get dot product and I can divide by magnitudes of vector A and B. I will note the angle between, cos of angle between them. Cos of angle between them. Then cos theta will be A dot B. What is A dot B here? A dot B is AX BX, AY BY, AZ BZ. Whole thing divided by, this is A dot B. A dot B. Whole thing divided by length of A and B. Length of A and B. Length of these two vectors, it means their magnitude. Magnitude of first vector multiplied with magnitude of second vector. So by this dot product of two vector upon magnitude of these two vector A and B, we will get cos theta. The angle between two vector can be determined. We will get theta as cos inverse of this. We can determine angle between two vectors if they are given in component format using this formula. First, note this formula. This is very easy to apply. Formula looks big, but it's very easy to apply. Note the formula. I will give an example again. Okay. I can know the angle between two vectors if they are given in component format. Note this. Vectors are given in component format. I can know the angle between vectors. Okay, so let us solve one example. One example on this part. This was 8th property, I think. Yes, 8th property. So, example on property number 8. Find angle between A vector which is I plus j minus k and B vector which is 2i plus k. These are two vector. These are two vector. We will find angle between these two vector. We will find angle between these two vector. How to find angle? I will give you the. I will solve this question for you. Okay, solution. The angle between two vector, if that is theta, angle between two vector is theta, then cos theta is given by A dot B upon magnitude of A, magnitude of B. A dot B. What is A dot B here? 1 into 2. Let me write the formula first. A dot B upon length of A, length of B. A dot B 1 into 2 plus 1 into 0. Here j cap is 0. 1 into 0. Here k is minus 1 and there k is 1. Whole thing divided by length of A, length of B. What is length of A? Root over 1 square plus 1 square plus 1 square. Minus 1 square. It will be remain 1 square. And length of B. which is 2 square plus, sorry, 2 square plus k component 1 square. So this will give you cos theta. Okay, this will give you cos theta. If we just solve it, 1 into 2, 2. 1 into 0, 0. Minus 1 into 1, plus 1, minus 1. Whole thing divided by, this is 1 plus 1 plus 1, 3, root 3. Into root over 2 square is 2 square 4, 4 plus 1, 5. So 2 minus 1, I will get 1 in numerator. Root 3 into root 5, I can write this as root 15. This is value of cos theta. If I know cos theta, then I can write theta. If I know cos theta, then I will also know theta. Theta is cos inverse 1 upon root 15. So this will be our answer. Remember? So whenever two vectors are given in component format, we can easily get the angle between vector theta by using this cos theta. How to know cos theta? Dot product of two vector divided by the length. Dot product of two vector divided by the length. This gives us cos theta. Dot product in component format is very easy. Length is also very easy in component format. So dot product by length of vectors, I will get theta. Is this understood? Very simple. We can know the length of vectors by component format. We can know the dot product. We know the angle between vectors. So whenever they give you two vectors and they want angle between them, they give you vector in component format and they want angle between them, we can easily get the angle. Okay. So one more property now left, ninth property of vectors. Ninth. Vector can also be used to know component of a vector or projection of a vector on another vector. Ninth property, to find projection oblique component. Remember, if this was a vector, this is your b vector, this was the theta, then dropping a perpendicular from b to a, this length was component of b on a, component or projection of b along a. B cos theta is projection oblique component of b vector along a vector. B cos theta. What is theta here? Theta is direction. Theta is angle between the direction. Angle. If B vector is making theta angle with a direction, B cos theta is the component. How to find this B cos theta? Sometimes they give you vector and they ask what is the component of one vector in the direction of second. How to find this B cos theta? Remember, the dot product of two is AB cos theta. Dot product of two vectors is AB cos theta. So here cos theta is there, B cos theta. For B cos theta, I may divide A vector dot B vector, by A. Very simple. A vector dot B vector by A. A vector dot B vector by A. Let me rewrite this. I will write B vector first, dot A vector. I can divide A vector by A. A vector divided by magnitude, of the vector itself. This gives you unit vector in direction of A. This is B vector dot A cap. B vector dot A cap. Yes. So projection or component of B along A is B vector dot A cap. I want projection of B, I will multiply B vector. I want projection in direction of A, I will multiply that with A cap. Simple. If you want projection of any vector, in some direction, multiply the vector with unit vector of that direction. This is how we find projection. Okay. To find projection, multiply vector with multiply, that is scalar multiply or dot product with unit vector of direction. If we want projection of B on A, I will multiply B with A cap. Simple thing. Understood? So time is over, so I should stop now. Okay, I also have a next class. So today we have covered dot product. I have given you almost all the properties of dot product. I think all properties is covered. Okay, we will do more practice in the next class on the dot product. I have also in between given you some examples. Okay, then in the next class I can give you more example. Clear? So I should stop here because you also have a next class. Thank you all of you. Bye. Take care. Take care, bacho. Bye bye.